In this video, we are going to learn about flotation. As we have already learned in our previous classes, that when a body is immersed in liquid, it experiences two types of forces. The two forces, namely the weight W of a body, which acts vertically downwards, and another force is the upthrust force, represented as Fb of the liquid, which acts vertically upwards. So these forces, weight and the upthrust, weight is equal to the volume of body into density of body into acceleration due to gravity. Whereas the upthrust force is equal to the volume of the submerged part of the body into density of the liquid into acceleration due to gravity. Excuse me. And also we have learned that there are three cases for the body to float or to sink. Case 1, when weight of the body is greater than the upthrust. If the weight of the body is greater than the upthrust, then the body will sink at the bottom of the liquid with the force of W minus Fb. Since W weight is greater than the upthrust, therefore W minus Fb will be the resultant force by which the body will sink down at the liquid's bottom. So it will sink at the bottom vertically downwards. This will be because of the density of the solid is greater than the density of the liquid. Next, case 2, when the weight of the body becomes equal to the upthrust. In this case, the body will be completely immersed in the liquid. The body will be completely immersed in the liquid, but it will not sink, it will float. So here you can look at the picture and you can understand how it's going to happen. The body is at the surface of the liquid, but it is completely submerged inside the liquid. Here the apparent weight of the body will be 0 and the density of the solid must be equal to the density of the liquid. Next case will be case 3. In case 3, if the body has the weight less than the upthrust, in that case the body will float in the surface of the water. Partially it is going to be above as well as below the surface. Weight W will act at the center of gravity and the upthrust will act at the center of buoyancy, and the apparent weight in this case also becomes 0. The density of the solid must be less than the density of liquid in order to float. So these were the three cases that we had already discussed in the previous class. So out of this we derived to the conclusion that for a floating body, weight of the body is equal to weight of the liquid displaced by the submerged part of the body. This is what we have also learned in Archimedes' principle. So W is equal to Fb. That means the weight of the body must be equal to the upthrust for a body to float, such that the apparent weight of the floating body becomes 0. Next, we discuss the principle of flotation. The principle of flotation states that the weight of the floating body is equal to the weight of the liquid displaced by its submerged part. This means if the body has a submerged part which displaces the liquid, then the weight of that floating body will be equal to that weight of the liquid displaced. Here we need to remember that if the body is submerged in different liquids, whether the liquid are of different densities, then the weight of the liquid displaced remains the same, because the weight of the displaced liquid will be equal to the weight of the body itself. Thus, the amount of liquid displaced remains the same whether the density of the liquid is higher or lower. Next, relation between volume of submerged part of floating body, the densities of liquid and the body. So here, let's say that the volume of the body is capital V, whose density is rho s. Here this is a Greek symbol which is known as rho, and rho in physics usually represents density. So this is the density of S. S means solid. So density of solid means the density of the body whose volume is capital V. And let small v be the volume of the body which is immersed in the liquid, and the density of the liquid is rho L. We have already learned that for a floating body, W is equal to Fb. That means the weight of the body must be equal to its upthrust. Weight W is given by the volume of the body multiplied with density multiplied with acceleration due to gravity. And upthrust is given by volume of liquid displaced into density of the liquid multiplied with acceleration due to gravity. In short, we can write volume of body as capital V, density as rho s because it's the density of the solid, into g, acceleration due to gravity, which equals to small v, that is the volume of the liquid displaced, into density, that is rho L, into g. This on further simplification, further simplifying the given expression, will get small v by capital V is equal to rho s by rho L. Now small v by capital V is written as the volume of immersed part of body by total volume of the body, which is equal to density of body by density of liquid. So this is the relation between the volume of submerged part and the volume of the entire body, density of the body and the density of the liquid. So this is the relation that these parameters hold. If this is the case, then we can understand it better with the help of an example. Ice has the density of 0.9 gram per centimeter cube, whereas the density of water is 1 gram per centimeter cube. So if you take an ice immersed in water, then the ice will float because its density over here, if you see, the density of ice is 0.9 gram per centimeter cube, which is less than the density of water, which is 1 gram per centimeter cube. So compared to the density of water, the density of ice is less. Thus ice will float, but since it is 0.9 according to our previous value, here volume of immersed part, that is 0.9 out of 1 will give us the density. The density is 0.9 out of 1 will give us the value, the volume of immersed part, that will be 9 out of 10. That means out here 9 out of 10 means 90% of its volume will be immersed inside the water and 10% volume will be above the water. Similarly, the second example we are going to take is a cork has the density of 0.75 gram per centimeter cube. So In water, it floats with 75% of its volume immersed inside the water and the remaining 25% volume above the water. In the case of ice also, we did the same kind of calculation. 0.9, 90% above, and 1 gram water in the density of 1 gram per centimeter cube. So 90% if it is inside the water, then 10% has to be above the water. 0.75 grams per centimeter cube is the density of the cork, and 1 gram per centimeter cube is the density of water, as here as well. So it will float with 75% of its volume inside the water and 25% above the water. I hope it's clear. So from this examples, we also need to understand that if the body has higher density, means there will be an increase in its weight. So more volume of the body will be submerged inside the liquid. And if more volume will be submerged inside the liquid, then it will experience more amount of upthrust, or it will experience high upthrust. If the body has lower density, then more volume will be above the surface of the water or surface of the liquid, and it will experience less amount of upthrust. So more the density of the liquid, if the density of the liquid is more, not the density of the body, but this time if the density of the liquid is more, then again the volume of the body submerged will be less. That will decrease, because more the density of the liquid, more the upthrust it will produce, and thus the body will get submerged. Its volume will be very less. Next, we move on to some of the applications of flotations. Number one, we all know that iron nail sinks, but an iron ship floats. This is the most important example which has been asked for the several times in ICAC. Volume of the ships are larger, thus its density is less than water. Now, why the volume of ship is larger? Because most of the space of the ship is occupied by air, because it has lots of rooms inside which is filled mostly by air. Thus its volume is increased, but its density is not as great, as large as the iron nail itself. Thus its density is less. Now if the density is less, then obviously the ship is not going to sink, the ship is going to float. There are a few interesting things that you need to know. Loaded ship gets more submerged in water than unloaded ship. Why? Because it's very simple. If ship are loaded with cargo, then its weight is going to increase. And if the weight is increased, that means it will get submerged more inside the water compared to the unloaded ship. Also, a ship submerges more in river water than sea water. Why? Because the density of river water is less than the density of sea water. Thus, sea water will produce more upthrust than the river water. Thus, when a ship goes inside the river water from sea water, it will experience more. The ship will get submerged more inside the river water, because the river water has less density and it will produce less upthrust. Next, each ship has a plimsoll line which is painted on its body, which indicates the safe limit for loading the ship. So there is a line which is drawn, which indicates that the cargo must have some limit. You cannot keep on putting the load on the ship, because if this line, plimsoll line, just touches the surface of the water, that means that is a critical stage, that more than that, if you put on the cargo, if you load on the ship more than that, then it might sink. So that plimsoll line just takes care of whether you are supposed to put the cargo more than that or not. Actually, we are not supposed to put more cargo, so that the plimsoll line should not touch the surface of the water. Also, an unloaded ship is filled with sand at its bottom. Since the unloaded ship is empty, so if it is empty, that means its density is very less, and the sea water will give more upthrust, and thus its center of gravity will be quite higher. In order to maintain the center of gravity to be more stable, the ship is loaded with sand at its bottom. Remember, it is loaded at its bottom, not on the deck. If it is, if it is filled with sand on the deck, again, the higher chances is that the center of gravity will not remain stable. Instead, it will be very unstable and it will readily sink. So these are the few important facts that we are supposed to know for a ship that will float. Next, number 2, floating of human body. Average density of the human body is 1.07 gram per centimeter cube with empty lungs. What do we mean by empty lungs now? Empty lungs means that if our lungs are empty, then the volume becomes less, and when the volume is less, obviously the density will increase. So in this case, when the lungs are empty lungs, that means the density will increase, and here the density with the empty lungs is 1.07 gram per centimeter cube. That means when we breathe in air, and if we somehow try to fill in our lungs with air, our volume will increase and hence its density will decrease. So when the lungs are filled with air, the density becomes 1.00 gram per centimeter cube. That is 1 gram per centimeter cube, which is which is equal to the density of water. Now, if both the body and the water both are having the same density, then what will happen? We have learned it in the previous, just before that, case number 2, that if weight is equal to the upthrust, then the body will not sink, it will float, but its body will be completely submerged inside the liquid. So here in this case, the density of the human body is exactly equal to the density of the liquid. So the human will not sink unless his lungs are filled with air. So it is easier to swim with the lungs filled with air, and also it will be easier for humans to swim in sea water than in fresh water. Again, you may know the reason why. Sea water has more density than the fresh water, so it will provide with higher amount of upthrust, and thus it will be very easy to swim in sea water compared to the fresh water. Next, floating of submarines. All of you know what submarines mean, right? So submarines, they have some tanks called ballast tanks, and they fill in water inside those tanks and get heavier, and they sink down. So in order to dive in the water, the ballast tanks are filled with water, and when they need to rise up, those ballast tanks will force the water out of it, and their density will be less and they will rise up. So this is a simple floating techniques that submarines use, and this techniques has been used by submarines, learning from some of the sea creatures, from some of the sea animals. All right, next we have floating of iceberg. Density of ice is 0.917 gram per centimeter cube. In the previous example, I have said that the density of ice is 0.9 centimeter gram per centimeter cube. So over here, to be more precise, to be more exact, density of ice is 0.917 gram per centimeter cube, and we all know that the fresh water has the density of 1 gram per centimeter cube. So it will float in fresh water with 91.7% of its volume submerged inside, and the remaining 8.3% of its volume will be above the water. And the density of seawater is 1.026 gram per centimeter cube. Look at the value, density of seawater, it is more denser than the fresh water. Thus, it will be, it has more density compared to the fresh water, 1.026 gram per centimeter cube. So, when ice floats in seawater, its 89.3% of its volume will be submerged inside the water, and the remaining 10.7% will be above the seawater. Also, a floating ice when melts into water, it does not change the volume of the water. You may think that when the ice melts, the volume of the water may rise. Actually, it's not like that. When ice is floating in the water, it will displace that amount of water itself. When it melts, that displaced water comes back as the same level. So the level of the water does not increase or decrease. So there is no change of the volume of water. So whatever the water was there, the same amount remains even after the ice melts into water. All right. So with that, we come to an end of our video. I hope you have understood what has been taught, and also please do the assignment which has been provided in the PDF format. And if you have liked the video, please press the like button. Thank you.